Welcome back to The Explainer. All right, let's just dive right into this, because today we're tackling a really fascinating economic puzzle. Now, it seems simple on the surface, but trust me, it reveals a super powerful idea about how we all make decisions.
So, let's start with this little thought experiment. Imagine your income doubles overnight. Awesome, right? But what if the price of everything you buy also doubles? I'm talking pizza, burgers, you name it. Just think about that for a second. Would you actually change how much pizza you buy? The answer, it turns out, is the key to unlocking a core concept in economics.
So, to solve our pizza problem, we've first got to understand how economists even think about your decisions. You see, they don't see your choices as just, random. They see them as the predictable output of a machine.
Yeah, that's right. Imagine a person, let's call him Ravi, as a kind of demand machine. You feed it some inputs, his income, the price of pizza, the price of a burger. Then the machine itself, that's Ravi's brain, his personal tastes, it processes all that data, and it spits out a clear output, how much pizza he's going to buy. Now, this machine, it has a formal name, of course. It's called the demand function. And yeah, it's often written as a formula, but don't let that scare you. All it's really saying is that your demand for a product, let's call it X, is just a function of its own price, the price of other stuff, and M, which stands for your money, your income.
So, the crucial point here is this. Our choices, they follow a logical pattern. Your buying behavior isn't just a whim, it's actually a mathematically determined response to the economic world you live in. And hey, because it follows a pattern, we can actually study it.
Okay, so now that we get the whole demand machine idea, let's go back to our pizza problem and start feeding some new numbers into it. Let's see what happens.
All right, look at this. In the first scenario, Ravi has an income of 100 rupees, a pizza costs 10, and he ends up buying 5 of them. Pretty straightforward. But now, check out the new situation. We've literally doubled everything. His income is 200, and the prices for both pizza and burgers are now 20. So what happens to that question mark?
This is the big question, right? Does doubling all the input numbers actually change the output of our little machine?
And the answer is a surprising and really simple no. His behavior doesn't change one bit. He buys the exact same 5 pizzas. But why? Well, because in real terms, in terms of his actual purchasing power, nothing has changed at all.
This special property, where scaling all the inputs proportionally doesn't actually change your decision, it has a specific name. Economists call this type of function a homogeneous function.
And to be even more precise, they say it's homogeneous of degree 0. Now that sounds super fancy and academic, I know, but it's really just a geeky way of saying that if you scale up all prices and income by the exact same amount, the change to demand is, well, 0. It stays right where it was.
Okay, now here's where things get really interesting. This property isn't just some random observation. No, it's actually backed by a powerful and, honestly, pretty elegant mathematical rule that proves why this has to be true.
It turns out any function that behaves this way, any function that's homogeneous, has to follow a very specific mathematical law. There's just no escaping it. It's baked right in.
And that law is called Euler's theorem. You can think of it as the engine running under the hood of our demand machine, the thing that makes sure all the parts work together perfectly.
Okay, so here it is, the formal statement of the theorem. And I know it looks intimidating with all those squiggly symbols. That's calculus. But please, don't worry about the calculus. So let's just ignore the scary math. The absolute key here is that for our demand function, that little n on the end is 0. And that one simple fact makes all that complicated math lead to a really powerful, simple insight.
For our demand function, what Euler's theorem basically boils down to is this. The combined effects of the price changes and the income change, they all have to cancel each other out. They have to add up to 0, period.
And this is the master key. This is the whole shebang. This mathematical rule is what connects our demand function directly to something you've probably heard of before, elasticities.
Euler's theorem gives us this incredibly neat final result. It proves that the price elasticity of demand, the income elasticity, and the cross-price elasticity, they aren't independent forces just floating around. They are locked together in a relationship where they must all balance out to 0.
Okay, wow. Let's do a quick recap here and see how this brilliant idea builds from a simple observation about a pizza slice all the way to a powerful conclusion about the entire economy.
This just lays out the entire logical chain perfectly. We started with the idea that demand is a function. Then we saw that this function is homogeneous. We learned that Euler's theorem is the mathematical proof behind this whole thing. And that proof leads us to one inescapable conclusion: the elasticities must sum to zero.
So the big takeaway is that these economic forces pulling on your decisions, they are not independent. They're all connected in a system that has to balance itself out. It's this beautiful, interconnected, self-correcting system. And that leaves us with a final thought to chew on. If we know that these forces must always cancel each other out, that they must always sum to zero, what does that really tell us about the limits of a company's power to actually influence our behavior?